Let's complicate it up. What's the best way of complicating something? Fraction. Okay. 2 is greater than or equal to p minus 2 over negative 3 is greater than or equal to negative 1. So this is odd, maybe at first, that we see that it's a compound inequality, but it's not given with the least on the left and the greatest on the right. But guess what? The very first thing we're going to do is multiply all sides by negative 3. And that's going to fix it in the very next step. So nothing to worry about. In order to get the p by itself, we got to get the p minus 2 by itself. We got to undo dividing by negative 3. So we're going to multiply all sides by negative 3. So 2 times negative 3, this middle thing times negative 3, the negative 1 times negative 3. And since we're multiplying all things by negative 3, that's going to switch the inequalities around. And that should take care of our weirdness from the beginning. Negative 3 times 2 is negative 6. We just have the p minus 2 in the center. Negative 3 times negative 1 is positive 3. And yep, everything looks good now. If we add 2 everywhere, negative 6 plus 2 is negative 4, is less than or equal to p, is less than or equal to positive 5. So in square brackets, we have the endpoints negative 4 and positive 5. Not so bad. Let's go ahead and do one more. Eight is greater than t plus 4 over negative 2 is greater than negative 5. Same sort of deal. We want to get the t by itself, so we got to get the t plus 4 by itself. We've got to undo dividing by negative 2, and we're going to do that with multiplying by negative 2 everywhere. 8 times negative 2 is negative 16. Switch the sign. T plus 4 in the middle. Switch the sign. Negative 5 times negative 2 is positive 10. So why does that work? It's because we are multiplying everything by negative 2. Negative 2 times 8. Negative 2 times negative 5. Negative 2 times the middle cancels those out. Just leaves us with the t plus 4. Since we're multiplying by a negative number, that switches these signs. Now to get the t by itself, subtract 4 everywhere. That gives me negative 20 on the left, t in the middle, and 6 on the right. This would be parentheses around the endpoints negative 20 and 6. Negative 2x minus 5 is less than 3. Sorry, is less than negative 3. Or 6 times x is less than 0. So solve them both. The first one, add 5 to both sides. Negative 2x is less than 2. Divide both sides by negative 2, which changes the direction of the sign. X is greater than negative 1. The other one, divide both sides by 6. We get x is less than 0. So take a number line and graph x is greater than negative 1. Take another number line and graph x is less than 0. If this was an and statement, it would be the overlap. So it would be everything between negative 1 and 0. But this is an or statement. It's both taken together. So if we were to draw them both on the same number line, it would cover the entire number line. So the answer to this one is actually all real numbers, negative infinity to infinity. And that is it for this topic. The topic is absolute value equations. The first objective in this topic, solving absolute value equations. So definition. What does this mean? Well, these two vertical bars mean absolute value. And in short, taking the absolute value of a number gives us the positive version of the number. So the absolute value of negative 3 would equal 3. The absolute value of positive 4 would be the positive version of what's inside, positive 4. So it doesn't take the opposite. It doesn't change negative into positive and positive into negative. It always makes it positive. So negatives become positive, positives stay positive, and the absolute value of 0 is itself 0. So notice what that means is that an absolute value can never be negative, because the absolute value of negatives and positives are both positive, and the only other option, if it's not negative and if it's not positive, it must be 0. The absolute value of 0 is 0. So an absolute value can never be negative. That's because an absolute value represents a specific distance. And remember that that distance is the distance to 0. So an absolute value of a number just means how far is it on a number line from that number to 0. And if we think of our number line, the distance from negative 3 to 0 is 3. The distance from 3 to 0 is 3. And that's why the absolute value of negative 3 is 3. And it's why the absolute value of positive 3 is 3. We can't have a negative distance. When we say how far is it from here to here, we would count 1, 2, 3, 3 units. So why am I bringing all of this up? Well, today's lesson is going to be on absolute value equations. In other words, equations that contain absolute values in them. So let's say we had something very simple like this. The absolute value of x is 3. Well, when we started talking about solving equations, before we looked at the process, we looked at simple ones where we could guess. And if we had x plus 1 equals 3, we would be able to guess that x must be 2 because 2 plus 1 is 3. And then we verified that we could have a process to do that called solving the equation. We can subtract 1 from both sides and get x equals 2 that way. Excuse me. Let's do the same sort of thing here with the absolute value. If the absolute value of something is 3, then that something can either be positive 3 itself or x equals negative 3. In other words, the thing inside could be 3 because the absolute value of 3 is 3. But the thing inside could also be negative 3 because the absolute value of negative 3 is 3. And this is going to be our strategy, how we think about solving these absolute value problems. What if I said, let's solve the absolute value of x equals 8? Well, then our strategy is going to be to split it into 2 equations. Either the thing inside is equal to the positive 8, or the thing inside is equal to the negative 8. Okay, not so bad. Not so bad. So what do I do when it's not so bad? I go ahead and I make it harder. Let's say we had the absolute value of w minus 2 equals 12. Well, the thing inside is either equal to 12 or negative 12. Because the absolute value of 12 is 12, the absolute value of negative 12 is 12. So that's 2 equations. Either the thing inside equals 12, or the thing inside, w minus 2, is negative 12. And then we can solve both of these. I can add 2 to both sides of this one and get w equals 14. I can add 2 to both sides of this one and get w equals negative 12 plus 2 is negative 10. So in order for this equation to be true, either w equals 14 or w equals negative 10. And just because we say or doesn't mean you're right if you say this one or you're right if you say that one. The correct answer needs both of these. Because what is or? Or is a union. That means the correct solution set would bring this one and this one in because it's the union. Everything from one with everything from the other. And would not be a correct thing to say here because and, when we're talking about connecting answers, is an intersection, and that would be an overlap. There is no overlap between the single point 14 and the single point negative 10. So we would say or because we want both. I know that's counterintuitive. You're thinking you want both of them, we should say and, but in math, when you want both, you say or. And means where it overlaps. So the solution set, we can say the whole statement, W equals 14 or W equals negative 10, or we can express it as a set with elements 14 and negative 10. And that's the same as if we would say negative 10 and 14, because in a set, order doesn't matter. This isn't an ordered pair. It's just a set with two things in it, and order doesn't matter. Just like with regular equations, you could also check your work. So if I wanted to make sure both of these answers are in fact correct, I can go ahead and plug in and check. So for W equals 14, that would be the absolute value of 14 minus 2 equals 12, which would be the absolute value of 12 equals 12, which checks. Over here, I can check W equals negative 10. Negative 10 minus 2 is negative 12. The absolute value of negative 12 is positive 12. So that one checks as well. Okay, so this is different. This isn't W minus 2 in the absolute value. This is just the absolute value of W minus 2 equals 12. Well, let's take a look at this. If our end goal is to solve for W, with an absolute value, we've only done examples where we have the absolute value equals something else. And that's what we want. We can't do anything with this until we get it. Absolute value equals something else. Then we can play our game, split it into the two equations. But we can't do it like this because the absolute value is not by itself yet. So, how would we approach this? How would we get the absolute value by itself? We can get rid of minus 2 with adding 2 to both sides. This gives us the absolute value of W equals 14, which means our two equations, W, the stuff inside, is either equal to the positive 14, or W, the stuff inside, is equal to the opposite, negative 14. Because the absolute value of 14 is 14, and the absolute value of negative 14 is 14. As a solution set, we just take those two values and put it in a set. Remember, order doesn't matter. The only thing about a set is we wouldn't list the same thing twice. Once it's in the set, it is in the set. Playing the isolate the variable game. What if we have 2 times the absolute value of x plus 32 equals 20? Well, again, just like we were solving for x, if we want to get the absolute value of x by itself, we would need to get 2 times the absolute value by itself. So we would need to get rid of plus 32. So I'm going to go ahead and subtract 32 from both sides. I'm left with 2 times the absolute value of x on the left. On the right, 20 minus 32 is negative 12. And at this point, it's not impossible that you might see the answer. I'm going to keep going, though. In order to get the absolute value by itself, I need to get rid of multiplying by 2. That means I'm going to divide both sides by 2. That's going to leave me with the absolute value of x on the left, and it's going to leave me with negative 12 divided by 2, negative 6 on the right. Do you see the answer? Do you think it's 6 and negative 6, or 6 or negative 6? That wouldn't be correct. If you don't believe me, go ahead and plug 6 in. The absolute value of 6 is 6. The absolute value of negative 6 is 6. Remember, I made a point of saying an absolute value can never be negative. Since an absolute value can't be negative, there's no solution. The answer is the empty set. Either this 0 with the line through it, or a literal empty set, because we can't solve this. There is no solution. There is no real number x that the absolute value is negative 6. No solution. I'm going to take another look. Another example. Let's look at the absolute value of z plus 8 minus 3 equals negative 3. So, just like our other examples, what do we do first? We want to get the absolute value by itself. So we need to get rid of minus 3, and we can do that with adding 3 to both sides. That'll leave us with the absolute value of z plus 8 on the left. It'll leave us with 0 on the right. What does it mean when we have 0 on the other side? Normally, if we had a positive number here, the stuff inside would either equal that positive number, or the stuff inside would equal the negative version of that number. But what is the number that the absolute value of is 0? The stuff inside here, z plus 8, must be 0, because the absolute value of 0 is 0. Subtract 8 from both sides. z equals -8. One answer only. A set containing one element if you needed to write it as a set. We can check our answer. If we plug -8 in, -8 plus 8 is 0. The absolute value of 0 is 0. 0 minus 3 is, in fact, -3. So it checks. Here's another one. So watch out for things that might happen trying to trip us up. If we want to get the absolute value by itself, we need to get rid of times 2. So I'm going to divide both sides by 2. That just leaves me with the absolute value of 3 minus 2t on the left, and 6 divided by 2 is 3 on the right. We can split this into 2 problems, either the stuff inside, so either 3 minus 2t is equal to 3, because the absolute value of 3 is 3, or the stuff inside, 3 minus 2t, is equal to -3, because the absolute value of -3 is 3. So to finish this off, we need to solve both of these. I'm going to give myself more room. That was our original problem. And we have worked it down to 3 minus 2t equals 3. 3 minus 2t equals -3. So I'm just copying that stuff, giving us more room to work. Solving here. To get the t by itself, we need to get the minus 2t by itself. That minus is attached to the 2. So to get that by itself, we have to get rid of this 3 out front. And that 3 is being added on because it's positive. So we subtract 3 from both sides. That leaves us with -2t equals 0. And if I just keep going, dividing both sides by -2 gives t equals 0. Over here, same thing, subtract 3 from both sides. That leaves us with -2t. 3 minus 3 cancels out. -3 minus 3 is -6. Divide both sides by -2. And we get t equals -6 divided by -2 is +3. If we check both of these in the original, they will work. If t is 0, then this is 3 minus 2 times 0, 3 minus 0, that's all just 3. Absolute value of 3 is 3, and 2 times 3 is 6. So that one checks. If we plug 3 in, 3 minus 2 times 3, 3 minus 6, 3 minus 6 is -3. The absolute value of -3 is +3. 2 times +3 is positive 6. So if you can visualize doing your order of operations, you can check in your head, or you could actually physically write it all out. If you have the time, do whatever you want to check your answer, either in your head or by hand. But you got to get to your answer using the algebra. You can't just look at it and go, oh, I think it's 0. Oh, I think it's 3. Oh, I think it's 0 and 3. You have to be able to do the work. Let's look at another. Two equals the absolute value of 7w minus 3 outside the absolute value plus 8. Hey, watch out for things that are trying to trip you up. If I want to get the absolute value by itself, I have to get rid of plus 8. I do that by subtracting 8. I do that on both sides. That means that I have the absolute value of 7w minus 3 equals 2 minus 8, negative 6. Right there. An absolute value cannot equal a negative number. So no solution. Or the empty set, where you can write it literally an empty set. If you miss that fact and instead you set up the stuff inside is equal to 6 or negative 6, the checking your answer is going to be what makes you realize you've done something wrong. So if I didn't notice that this was absolute value equals negative, and instead did 7w minus 3 equals 6, 7w minus 3 negative 6, solve those both, get w equals 2 numbers. Neither of those numbers would work, which is why we are encouraged to check our answers. Normally it's a step I don't mind skipping, but if we're involved with absolute value signs, if we're involved with a square root sign, it's always better to check, because that's where a lot of things might pop up as answers that don't actually work. And sometimes it's not a matter of you missed something. Sometimes the checking is the only way to find out that it doesn't work. If you looked at this problem, absolute value of w minus 2 minus 3 equals negative 1, and you went no solution, I have tricked you by making you think that I was tricking you. No solution is wrong here. And you might go, wait a minute, you said if it equals a negative, this equals negative 1. The absolute value does not equal negative 1 here, because the absolute value is not by itself. We would have to add 3 to both sides to get the absolute value by itself. And negative 1 plus 3 is positive 2. So there is a solution. Either w minus 2 is 2, or w minus 2 is negative 2. Add 2 to both sides, w equals 4, or add 2 to both sides, w equals 0. So W equals 4 or W equals 0. And both of those check. If we plug 4 in, 4 minus 2 is 2. Absolute value of 2 is 2. 2 minus 3 is -1. If I plug the 0 in, 0 minus 2 is -2. Absolute value of -2 is +2. +2 minus 3 is -1. So 0 and 4 are our solutions. So be careful when you have that equals a negative. Make sure it's actually the absolute value itself that equals the negative, and there's not things that can move around first. Absolute value equals absolute value. What could we possibly do here? Well, we don't need them both to be absolute values. In fact, we get the same answers whether this one's an absolute value and that one is not, or the other way around. This one's an absolute value and that one's not. I'll show you. If we have the absolute value on this one, we don't need the absolute value on this one. Now, we haven't had this yet. We haven't had the absolute value on one side and the other side have a variable in it. But it's not going to change what we do. Either the stuff inside, either the 2x minus 5 equals exactly this x plus 1, or the stuff inside, the 2x minus 5 equals, if this represents one of the things, then the opposite of this, the negative version, if you want to think of it that way. When we had a positive number, we would have the stuff inside as that positive number, or the stuff inside equals the negative version. So that's what we have here. The x plus 1 and the negative of the x plus 1. Now, I'm going to try to stop saying that. I'm going to call this the opposite of x plus 1. And that's because sometimes this will be the negative number and that'll be the positive number. Let's say x was -5. If x was -5, then x plus 1 would be -5 plus 1 would be -4. So this side would be the negative, and this would be the one where we would have to take the opposite of the negative number, and it would be the positive one over here. So I don't want to say x plus 1 and negative x plus 1. I'm going to start saying x plus 1 and the opposite of x plus 1, because that is how this is properly read. And thinking about it that way makes a lot of things make sense, as opposed to thinking about it as a negative. From here, we just solve both. So 2x minus 5 equals x plus 1. I can subtract x from both sides. 2x minus x is x. So x minus 5 equals positive 1. I'll come back here. Over here, I have to distribute this negative, and I get negative x minus 1, the opposite of x and the opposite of positive 1. So here I would add x to both sides. 2x plus x is 3x minus 5 equals negative 1. I'm going to go ahead and solve both of these, but I need more room. I'm going to come up here. X minus 5 equals 1, or 3x minus 5 equals negative 1. Add 5 to both sides here. I get x equals 1 plus 5 is 6. Add 5 to both sides here. I get 3x equals negative 1 plus 5, positive 4. I get x equals 6. Divide both sides by 3 here. X equals 4/3. I need both of those answers. And both of these do check in the original. Now, I said it doesn't matter. One or the other can be the absolute value. Doing it this way, where we had absolute value equals the rest of the stuff, we got a solution set of 4/3 and 6. And you can't see any of that. Let me write that again. We got a solution set of 4/3 and 6 when we had the absolute value on the left. Now let's go ahead. You don't have to do it both ways. This is still me showing you, hey, it really doesn't matter. Let's look at the same problem, but this time, that's an x plus 1. Let's go ahead and leave the absolute values on the right. Well, then the stuff inside x plus 1 is either equal to exactly what's on the other side, or the stuff inside x plus 1 equals the opposite of the other side. The stuff inside equals the positive. The stuff inside equals the negative. And notice, again, I'm writing the opposite of the whole side. Because what happened here? We're going to have to distribute that negative 5. It becomes negative 2x plus 5. The negative sign gets distributed. The opposite of 2x is negative 2x. The opposite of negative 5 is positive 5. Since I've already started solving this side, I'm going to go ahead and add 2x to both sides. That gives me 3x plus 1 equals 5. Subtract 1 from both sides. 3x equals 4. Divide both sides by 3. There's the x equals 4/3. Sorry, that's in the corner down there. This one's shorter. Subtract 2x from both sides. x minus 2x is negative 1x or negative x, plus 1 equals negative 5. Subtract 1 from both sides. The opposite of x is negative 6, which means x is positive 6. 6 and 4/3. Same answer we got when we had the absolute value here and the x plus 1 without. So all of that showing you the problem basically twice, just to convince you it doesn't matter which absolute value you drop, but you have to drop one of them. Let's do another like that. I won't show it both ways though. Let's take a look at the absolute value of 3x minus 4 equals the absolute value of 2x plus 1. I'm going to go ahead and leave the absolute value on the left just because, I don't know, I like absolute value equals looking like absolute value equals. But like we just saw, it doesn't matter. So I'm going to drop it on this side, just a plain old 2x plus 1. Now, absolute value equals this. So either the stuff inside the 3x minus 4 equals exactly the 2x plus 1, or the stuff inside the 3x minus 4 equals the opposite of the 2x plus 1. So over here, subtract 2x from both sides. X minus 4 equals 1. Add 4 to both sides. X equals 5. Over here, I'm going to distribute the negative. 3x minus 4 equals negative 2x. Negative 2x minus 1. So I'm going to add 2x to both sides. 5x minus 4 equals negative 1. I'm going to add 4 to both sides. So 5x equals negative 1 plus 4. Positive 3. And if I divide both sides by 5, I'll get x equals 3/5. So my two answers in my solution set, 3/5 and 5. Don't fall for the trap here. In the absolute value of 3z minus 2, then outside the absolute value plus 8 equals 1, we have to start by getting absolute value equals. We can't solve it until it's in absolute value equals form, not absolute value plus 8 equals. So we've got to get rid of that plus 8. We get rid of plus 8 with minus 8 from both sides. That leaves us with the absolute value of 3z minus 2 on the left, and then 1 minus 8 is negative 7. And so many people get used to setting what's inside equal to a positive and a negative that they'll miss the trap here, or I should say they'll fall into the trap here, and they'll say 3z minus 2 equals -7, 3z minus 2 equals +7. But you can't do that. Look at what this is saying. This is saying that the absolute value is equal to a negative number. And absolute values can only be equal to a positive number. When we take an absolute value, for instance, the absolute value of 3z minus 2, we get a positive answer. At smallest, we get an answer of 0, but we can never get an absolute value equals a negative. So there is no solution here. There is nothing we can plug in for z that's going to give us something that when we take an absolute value of it, we're going to get -7 at the end. Not even -7. The absolute value of -7 is +7. There's no way to get the absolute value of something equal to a negative. An absolute value can never be equal to a negative number. What if we had the absolute value equals an absolute value? Well, it turns out that we can just assume that there is one absolute value. So get rid of the absolute value around the 5 minus x, solve like normal, and you will get the correct answers. In other words, x minus 3, the inside of the absolute value on the left, is either going to equal 5 minus x, or the inside of the absolute value on the left, x minus 3, is going to equal the opposite of the right side, the opposite of 5 minus x. Solve them both. The one on the left, add x to both sides. That gets rid of the x on the right of the left equation. Adding x to both sides gives us 2x minus 3 equals 5. Then add 3 to both sides to get 2x equals 8. And then divide both sides by 2 to get x equals 4. The right equation, the second equation, the one where we say that the inside, the x minus 3, is equal to the opposite of 5 minus x. We distribute the negative. X minus 3 equals -5 plus x. Negative times negative is positive. Adding 3 to both sides here is something we don't do yet, so forget I said that. First, we need to get the x's on one side. Subtracting x from both sides gets rid of the x on both sides, leaving us with just -3 on the left and leaving us with just -5 on the right. -3 minus 5 is a false statement. There is no solution to the second equation. Therefore, our only answer is x equals 4. And that is the end of this topic. The topic is absolute value inequalities. Objective 1 in this topic is solving absolute value inequalities of the form absolute value of x less than a. So we're going to solve things that have absolute value less than. And if a is a positive number, then absolute value less than is equivalent to saying between. The stuff inside the absolute value is between -a and a. In other words, when we have absolute value less than, we drop the absolute value symbol, add another less than on the left, and take the opposite of the number from the right and place that on the left. So instead of just an a on the right, we have another less than and the opposite of a. The second objective in this topic is solve absolute value inequalities of the form absolute value of x greater than a. So now we'll take a look at absolute value greater than. If a is a positive number, then the absolute value of x greater than a is equivalent to x less than negative a or x greater than a. In other words, drop the absolute value sign and read it as is for one of them. Drop the absolute value sign, flip greater than to less than, flip positive to negative for the other. Let's talk about absolute value inequalities. Something that can't ever happen. That's what we started talking about. We said that an absolute value can never be negative. What's another way of saying it can never be negative? Not always positive. That's really close. Always positive or what? If we think of our number line, there's not two choices, positive or negative. There's three choices. You're either negative, you're positive, or you are zero. So we consider all three cases. If we can't be negative, that means we can be positive, but we could also be zero. We can be equal to zero, or we can be greater than zero. Positive things are greater than zero. So this is something that is always true. It is always true that an absolute value is greater than or equal to zero. So when we see this, this is a special case where our answer is going to be all real numbers. What if we had the absolute value less than zero, not or equal to? Well, this one is never true. An absolute value can't be less than zero, because that means that the absolute value would have to be negative. Things less than zero without the or equal to are negative. An absolute value is never negative. So this is something that would have no solution. What about if it did have the or equal to here? Absolute value less than or equal to zero. Well, remember what this means. This symbol means less than or equal to. We just showed that if it was just less than zero, there would be no solution. So that means, since there's no solution to the less than part of it, we can simplify the absolute value less than or equal to zero to the absolute value equals zero. And remember what we did when we had the absolute value equals zero. We just dropped the absolute value signs. So the stuff inside without the symbol equals 0 is how we would solve that. Let's actually do one like this. If you're confused what I'm saying there, maybe if we actually have some things. Let's take a look at the absolute value of x minus 5 is less than or equal to 0. Well, less than or equal to, this means the absolute value of x minus 5 is less than 0, or the absolute value of x minus 5 equals 0. An absolute value less than 0, that would be an absolute value negative. That means this has no solution, because an absolute value can never be less than 0. Absolute value of x minus 5 equals 0. Well, that's the same as x minus 5 equals 0, because there's no positive negative version to split this up into. So x equals 5 is our only answer. So the solution set would just be the set with the element 5. Now, to make this be an example of something else that we did, if we had the absolute value of x minus 5 is greater than or equal to 0, well, an absolute value can only ever be greater than or equal to 0. It can't be less than. This would actually be all real numbers, because there's nothing we can plug in that doesn't make it true. If we put a negative number in, a negative number minus 5 is even more negative, but the absolute value is going to be positive, greater than or equal to 0. If we put in a positive number greater than 5, like 6 minus 5 is positive. Absolute value of positive, greater than or equal to 0. If we put in a number less than 5, but positive, like 1 minus 5 is negative 4. Negative absolute value becomes positive, greater than or equal to 0. So I did the negatives. I split the positives around 5. What about 5 itself? 5 minus 5 is 0. The absolute value of 0 is 0. 0 is greater than or equal to 0 because of the or equal to. So all real numbers. What if instead of 0 here, I had a negative number? Like negative 4. Well, think it through. All absolute values are greater than or equal to 0. That means since all greater than or equal to 0 things are also greater than or equal to negative 4, it's still all real numbers. Because you know what's greater than or equal to negative 4? 0. And all positive things, those are all greater than or equal to negative 4. Absolute values can only be zeros and positive things. All real numbers in interval notation is negative infinity to infinity, because it is all real numbers. It is the whole number line from negative infinity to and through infinity and beyond. Why does infinity get a parenthesis, never a square bracket? Because infinity is an idea. It's not a thing. Since it's not a thing, it can't be equal to that thing. Since it can't be equal, it can't have a square bracket. That's why the infinities are a special case that are just parentheses. It's the idea of forever in the positive direction. Negative infinity is the idea of forever in the negative direction. Okay.